Okay, so we're going to look through some examples of combinations dealing with probabilities. So I've got a few examples here to go through. All right, so my first question, a cat has a litter of 6 kittens and you plan to adopt 2 of the kittens. And how many ways can you choose 2 of the kittens from a litter? So a good question to ask, does the order matter? And in this situation, the order does not matter because you're just going to pick 2 and bring them home with you. So we're going to do a combination. And with this combination, there are 6 items to choose from, cats, and I'm going to choose 2 of them. Then I just use my calculator. So 6, oops, too far. Want my NCR, and then 2. And there are 15 different ways that I can choose 2 items from my set of 6 kittens. All right, for number 2, an amusement park has 11 roller coasters. And how many ways can you choose 4 of the roller coasters to ride? In this case, order does not matter because you're just going to ride them. Now, if we were going to look at the different order of roller coasters we could go in, it would be a permutation, but here I'm just choosing 4. It's a combination, 11 items, and I'm choosing 4 of them. There are 330 different ways to do that. Alright, so 4 students from a 30-member math club are selected to organize a fundraiser. How many groups of 4? So I'm just going to group the 4 students together, so I'm not concerned with the order that I'm choosing. So it is a combination of those 30, and I am choosing 4. So 27,405 different groups. Okay, here comes some probability using combinations. So the school has 5 Spanish teachers and 4 French teachers. The school's principal randomly chooses 2 of the teachers to attend a conference. What is the probability that the principal chooses 2 Spanish teachers? So when I'm looking for probability, I need a fraction. So I'm going to have my event over my sample space. So let me look at my sample space first and see how many choices there are. So out of these 9 teachers, the principal will choose 2 to attend a conference. So this will be my denominator because it's my total sample space, my number of options. And there are 36 different ways to choose any 2 teachers. So for my event, I want to choose 2 teachers that are Spanish teachers. So for my event, I'm only looking at the Spanish teachers. Order doesn't matter. So I have a 5C2 here, which is 10. So 10 out of 36, which then I can reduce to 5 out of 18. So if you're looking for a probability, we're going to have some sample space, which includes everybody, and then my event is special qualifications. So looking at number 5, there are 6 fiction books and 8 non-fiction books on a reading list. Your teacher randomly assigns you to 4 books to read over the summer. What is the probability you're assigned all non-fiction? So my sample space, I've got to read 4 books at a total of 14 of them. So there are 1,001 ways that can happen. So that will be my denominator. And then my event is choosing all nonfiction. So choosing 4 books that are nonfiction out of this 8. Oops, wrong button. Will be 70. I'm not going to reduce that on my own, but I can use my calculator. This reduces to 10 out of 143. All right, I'm going to skip on down to some more complex problems. So number 8, I have a bouquet of 6 flowers. It's made up of randomly choosing between roses and carnations. So I'm looking for the probability that the bouquet will have at most 2 roses. So I'm going to look for my sample space, and I'm going to have 2 choices, either a rose or a carnation out of these 6 flowers. So my sample space, I'm not going to use a combination because I can choose each of the 6, and out of the 6 options I can do a rose or a carnation. So I have 2 choices for each. So if you're choosing things that fill in a space, I would recommend blanks. So here are my 6 flowers, and I have 2 choices for the first, 2 choices for the second, 2 for the third, 2 for the fourth, 2 for the fifth, and 2 for the sixth. So these are the different options that I have for those flowers, because I could pick a rose or a carnation, a rose or carnation, a rose or carnation, a rose or carnation. So 2 times 2 times 2 times 2 times 2 times 2 is 64. So my denominator here is 64. Now, my event, I want to have at most 2 roses. So out of my 6 flowers, I can have no roses, I can have 1 rose, or I can have 2 roses. So I can do a combination for each of these. So with no roses, out of my 6 flowers, none of them are roses. For 1 rose, out of my 6 flowers, 1 of them is a rose. And then for my 2 roses, out of my 6 flowers, 2 of them are roses. So here I do a combination because I'm looking at the full bouquet together, and this is how many roses I have out of those 6 flowers from each one. Since this, I have no roses, or 1 rose, or 2 roses, and that satisfies my at most, I'm going to add these together. So 6 choose 0 is 1. Let me put this on here. 6 choose 1 is 6. And then 6 choose 2 is 15. So all together there are 22 different ways that I can have no roses, 1 rose, or 2 roses. Okay, and then this reduces to 11 out of 32. So sample space, I was choosing options. This will happen if you're looking at the license plate or flipping a coin, but here I'm choosing 1 of 2 flowers to go in. All right, my number 9 is similar. So I have a bag of fruit contain 10 pieces of fruit chosen randomly from a bins of apples and oranges. What is the probability of a bag containing at least 6 oranges? So for my sample space, there are 10 pieces of fruit. Each piece of fruit could be an apple or an orange. So this is going to be 2 options, 4, 5, 6, 7, 5, 6, 7, 8, 9, 10. 2 options each, so I'm looking at 2 to the 10th power, which is 1024, as my denominator for the total options for the sample space. All right, for my event, I want at least 6 oranges. So I want 6 oranges, 7 oranges, 8 oranges, 9 oranges, or 10 oranges. So each of these is going to be a combination of my 10 fruits. 6 of them are oranges. So out of my 10 fruits, 6 of them are oranges. Out of my 10 fruits, 7 of them are oranges. Out of my 10 fruits, 8 of them are oranges. Out of my 10 fruits, 9 of them are oranges. And then out of my 10 fruits, 10 of them are oranges. And then I add these up. So 10 choose 6 is 210. 10 choose 7 is 120. 10 choose 8 is 45. 10 choose 9 is 10. And then 10 choose 1 is 1. So I'm going to add those up. 210 plus 120 plus 45 plus 10 plus 1 will be 386. And then I don't trust my mental math to reduce that, so I'm going to use my calculator to simplify, and I get 193 out of 512. All right, and then here's a two-part question. So if there are 21 students in your class and the teacher wants to send 4 students to the library on each day, the teacher will choose the students to go to the library at random each day for the first 4 days from the list who have not gone already. So we're looking for the probability that you will be chosen to go on the first day. So my sample space is going to be the total number of students, and I'm choosing 4 of them. So 21 choose 4 is 5,985. That's going to be my denominator. My event is that you get to go on the first day. So out of the class, there'll be 4 kids who go. So here's me going. And then here's 3 more kids going, because there's going to be a total of 4. So in order for me to go, that's 1, choose 1, because I am the only student who is myself, can be chosen, and this number is 1. Then I need to choose, this is an and, because I need myself and 3 more. So in order to get the 3 more kids, I now have 20 kids in the class that can be chosen, and I'm choosing 3 of them. This is 20 because I have already been chosen to go to the library, so there's only 20 left on the roster. So 20, choose 3, is 1140. And then I reduce my fraction with my calculator, of course. All right. So for my second part in this question, you have not been chosen to go on days 1 through 3. What is the probability that you will go on the 4th day? So a little bit of calculating here. On day 1, 4 kids went. On day 2, 4 kids went. On day 3, 4 kids have gone. So right now, 12 kids have gone to the library. So if I'm going to go for the next day, my number of students to choose from has diminished because these 12 names are now crossed off the list. So my sample space, I'm still choosing 4 students, but out of those 4 students, my list, I had 21 total. 12 have already gone. There are now 9 students to choose from because I need to take out these 12 that have already gone. So 9 choose 4 is 126. That is my denominator. All right, my event is for me to go. So there's me. And then here are 3 of my classmates. So 1 choose 1 way to choose for myself to go. Now I need to choose 3 more students. So again, there were 21 total. 12 have already gone, so that leaves me with 9. But I just took my name off the roster, so there are 8 left to choose from. 1 choose 1 is 1. And then 8 choose 3 is 56. So this is 56 out of 126, which is 4 out of 9. All right, that's it. Have a good day.